Hi everyone. In this video we want to find the angle of turn on the free end and the axis that's behind spline the axis. Here two different cross-sectional areas. We use our angle of the torsion formula. That equal to the sum of all the parts have TL and GJ, and each of the same steel, so it will have a stiffness model of 77 gigapascals. Is constant. And the torque, the inner part, is going to the constant in everything. Then we want to do, if we define this small section as the section 1 and the big section is the section 2, section 1 and section 2. Then what we want is to realize what G is for the section 1 and also for the section 2. So the formula we use for the polar moment of inertia is only P more than 2, P than 2, times C2 to the power of 4 less C1 to the power of 4. Now that is the previous video where C2 is basically the distance from the center of the axis. Here surface of the bar and C1 was if this gap, that is the distance for the internal surface. So these are the solid numbers, then C1 will really go to 0, is so for G1. Here we have P more than 2 times the radius, and that is the radius in the 15 millimeters. But we want to write this in the meters, so 0.015 meters to the power of 4. And that will give is us now 0.0795 times the less 6 meter of the power of 4. Now we want to point it in units of the lesson 6 because
so he takes the polar moment of the inertia for section 2. Here we have P1. About that, it's a solid number, so know that C1 is going to be 0. So we have only the edge with the radius of 30 millimeters. So let's put that in the meters of 003 meters. So let's put that in the power of the wheel hip is 0.273 twice the 10 minus 6 meters to power 4. Now we will want to connect this in our triangle equations. So our triangle, we will the parts on wheel 2 part on first. So we have 0.5 kilonewtons times the tail hit the station, that is 0.3 meters. Heat in this is going to be more than.
We go with drop all that stuff, so we're just going to be left with 0.5 times 0.3 and then the bottom part. Here we're left 0.0795 times 77, using this 10 at less seats and all these other units. Then sides, here we have 0.5 times 0.4, and this was all that is left more than 1.27 twice 77. So if we simplify this for a little more, we will discover that this first term here is equal to 0.0245 radians, and this second term here only works of 0.0020 radians. And if we only add them together, we will discover that is our inflection angle. Let's try to. Here the angle of rotation is equal to 0.265 radians. Okay, that's the rolling angle. This for free, and yes, you want to know its difference. and we'll have to do simple multiply by our factor here. 108 then is measured 108 degrees is be radians, and this gives use angle to draw it that free and there of a point 5 degrees 0.00 to sit 0.0265 times 108 divided by p gives as 1.52 degrees.